All of you listen here. Classification of conductors and semiconductor insulator you explain, right? You are different with different property. You try to explain conductor, semiconductor, insulator. This is the question here. And first to write according to electrical conductivity how conductor, semiconductor, insulator are classified. According to electrical conductivity. Now according to electrical conductivity, conductors are having high conductivity 10 to the power 2 to 10 to the power 8 ohm into meter inverse, and semiconductors are having mho into meter inverse, mho into meter inverse, 10 to the power 5 to 10 to the power minus 6 mho into meter inverse. Okay, conductivity unit. And this one 10 to the power minus 11 to 10 to the minus 19, very less. So you can understand here for insulator conductivity is very less. So you can tell basically low conductivity. Low conductivity. For insulator, low conductivity. Yes or no? And for conductors coming what? High conductivity. High conductivity. High conductivity. Okay. So according to electrical conductivity, you classified conductor, semiconductor, insulator. Similarly, another property you take electrical resistivity. Okay, that is basically rho. Rho is given as 1 by sigma. Or rho basically unit is ohm into meter. So it is reciprocal of conductivity. So it will come 10 to the power minus 2 to 10 to the power minus 8 ohm into meter, which is low. So for conductors you have low resistivity. What you have? Low resistivity. Low resistivity. Low resistivity. And for semiconductor you have 10 to the power minus 2 to 10 to the power minus 5 to 10 to the power plus 6 ohm into meter. And for insulator you have 10 to the power plus 11 to 10 to the power plus 19 ohm into meter. Ohm into meter. Okay, ohm into meter unit. Now for insulator you can check your resistivity is high. So you can write here it is high resistivity. High resistivity. Okay. So insulator does not conduct electric current, right? Because it's a high resistivity and low conductivity. But conductors conduct current. The next point is energy band diagram. If in terms of energy band diagram, we'll try to understand energy band diagram. Come please. So what is this energy band diagram? Now the diagram of conduction band and valence band, we'll see how they are arranged. Now suppose I am taking in white color one band. This band I am telling is conduction band. Conduction band. Another I am taking in yellow color one band. That one I am taking as what band? Valency band. VB I am writing valency band. Now you check here what is happening. Now here conduction band and valency band they are overlapping. What they are doing here? Overlapping. Yes or no? They are overlapping. So here overlapping is happening. Conduction band and valency band they are overlapping. Okay, they are overlapping each other. Okay, overlapping means are you getting? Conduction band, valency band, please skip it. Their energy levels are mixed here. So that means which electron is available for valency band, that is also available for what? That is also available for conduction band. So overlap is there, overlap of conduction band and valency band. Now for semiconductor we'll see. Okay, let me take conduction band and valency band. Now conduction band, between conduction band and valency band there is little energy gap is there, energy gap which is less than 3 electron volt. Less than 3 electron volt energy gap is there. Okay, so the above one is your conduction band and below one is your valency band. Okay, so less than 3 electron volt one energy gap is there. Now next for insulator if you will see, for insulator there will be high energy gap. More energy gap will be there between conduction band and valency band. So this is your conduction band and this is your valency band. So here energy gap is more, Eg. That Eg is greater than what? 3 electron volt. So for insulator, your energy gap is coming greater than 3 electron volt. Yes or no? So this is your valency energy band. Valence energy band. Okay. But tell me what will be energy gap here? Energy gap in conductor, it will be 0. 0. Why energy gap 0? Because they are overlapping. Conduction band, valence band are overlapping. Please complete this. Conduction band and valence band are overlapping, so that's the energy gap is 0. Yes or no? Did you understand about energy band diagram? See, sometimes question will ask, you classify conductor, semiconductor and insulator based on energy band diagram. Then only this third point you have to write. Only this third point you have to write. Yes or no? Only third point, 3 conductor, semiconductor, insulator, you do the pictures. That's it. That is the energy band diagram explanation. And remember, there are no electrons in the conduction band in the insulators. Okay. At normal temperature, it will be not there. But at a normal temperature in semiconductor, some electrons can come to conduction band. So conduction band will be partially filled, like that you can tell. But for insulator, conduction band will be empty. No electrons will be there for insulator. Okay. So please note it down all these points. Classification, and particularly if energy band diagram classification they are asking, only third point you write for 2 mark question. Okay. So this all pictures you have to do. You write which is conduction band. Here I have written shortcut. CB means conduction band. VB means valence band. Yes or no? So remember. Now next lesson. Again we will continue, some other points we will try to write. Please you complete. Okay. Now next page, listen all of you. Next page. Some other property. First you write here energy gap. Number 4 write. Same thing you continue. Serial number. You continue again same thing. Serial number, it is a property. Serial number property. Then next. Next conductors. Conductors. Semiconductors. To continue. Continue. Then here insulators. Insulators. Like that you would continue. Anyone is writing the previous page? Complete please. Darshan, you check properly. For insulator, there are so much energy gap is there. You are combining and writing both the band. Randomly you cannot do. There is certain things are there with writing accordingly. Here less energy gap, here big energy gap. Yes or no? Then you are joining and writing. That is not good. Okay. Completed. Next I am going to next point, fourth point, which is energy gap. Already written here in third point itself, but again we will write in fourth point. Okay. Please complete. Completed? Okay. Next listen. Fourth point. Those who did not complete from your friends. Now see here. Fourth property is, well, let's take energy gap. In terms of energy gap, you check. Energy gap. Energy gap is basically symbol we give Eg. So remember, for conduction band, I can write energy gap equal to 0 electron volt. Yes or no? 0 electron volt. For semiconductor, energy gap is less than 3 electron volt according to your NCERT book. And for insulator, it is greater than 3 electron volt. And here, suppose for example, you write, okay, for example, you will write for silicon, okay, silicon energy gap will be 1.1 electron volt around, and germanium, if you check the semiconductor material, it is equal to 0.7 volt around, 0.7 electron volt, 0.7 electron volt. Okay, and here if example I'll give, diamond, you can give diamond. Diamond is around, energy gap is around, is around 6 electron volt. How many electron volt? 6 electron volt. A diamond, if you see, it is 6 electron volt. So this many points to remember about energy gap. Where what energy gap is there? So one more questions can come. Now fifth question or fifth property. Fifth property, remember, energy gap understood. Now charge carrier. Charge carrier and what is the valence band and conduction band conditions you can write. Okay, so write first one, write it 50 point, write condition of valence band and conduction band. Condition on or condition of valence band, VB I am writing valence band and conduction band at ordinary temperature. At ordinary temperature. At ordinary temperature, what is happening to conduction band and valence band, we will try to see. Okay, now listen all of you. Conduction band and valence band are completely filled. You can write here, conduction band and valence band are completely filled, because they are overlapping, they are not completely filled. Or you can write, or conduction band is partially empty. CB means conduction band is partially empty. This one also you can write, partially is partially empty. Next, for semiconductor, listen, valence band partially empty, conduction band partially filled, right? Valence band is partially empty and conduction band is partially filled. Because of temperature, electrons will get energy and they will go to conduction band, partially empty. Okay, now listen, for insulator, valence band is completely filled and conduction band is completely empty. Okay, right, valence band is completely filled and valence conduction band is empty. conduction band is empty, fully empty, or you can tell unfilled. Yes or no? Completely filled. Valence band is completely and conduction band is empty. So this is the condition of valence band and conduction band at ordinary temperature. Remember this. 1 mark questions can come, theoretical questions. Okay. So you can understand also better in this energy band diagram. All of you listen carefully. In this energy band diagram, you see if any electron is available, in conduction valence band for semiconductor, then it needs less energy to go for conduction band because energy gap is less. But here huge energy gap for in insulator. So now what will happen? How much energy you give? It cannot reach valence band. Electron cannot reach conduction band. Okay, you need very high energy. By that time now your material will be like what now, it will be breaking. Bonds will break and material will break. Okay, so what is happening here? Now for insulator, valence band electron needs more energy to go for conduction band. Then only current conduction will take place. But it is practically impossible. So that's why it normal materials, those are insulators, rubber, plastics and all. They are basically insulators. They don't conduct electricity because this electron goes only. Conduction band. Then only electricity they will conduct. Yes or no? Okay. So that is what the reason it is not happening there. Current conduction. Okay. So you understand about this valence band and conduction band conditions. Valence band is completely filled for insulator. But that electron is not going to conduction band. Conduction band is empty. If conduction band is empty, no free electrons, no conduction of currents. That's why they are insulators. Yes or no? Okay. So remember 5th point. Now 6th point, listen. At the 6th point, current carriers. What are the current carriers? Current carriers. What are the current carriers? For conductors, you remember free electrons. Conductors, it is free electrons are the current carriers. And for semiconductor, basically it is electrons and holes. We'll understand what is electron and holes. Electrons and holes. And next, for insulator there is no current carriers because it does not conduct electricity. So write down 6th point. 6th point complete. Now 7th one. 7th one will try to understand about temperature coefficient of resistance. Write down all of you. Temperature coefficient of resistance. Temperature coefficient of resistance, that is called alpha, basically alpha. So what is temperature coefficient of resistance? Alpha. Now for conductor case, it is basically positive. So its resistance increases with the increase in temperature. That's why it is positive. Alpha is positive. Okay, alpha is positive or greater than 0 basically. Okay, alpha is positive. Positive. Or basically you can tell greater than 0. Alpha is greater than 0. Okay, here alpha is negative for semiconductor. So this is negative. Alpha is negative. Negative means less than 0. Alpha is less than 0. And same case for insulator. Remember, alpha value positive, negative, then negative. Alpha value positive, negative, negative. For semiconductor and insulator, alpha value is negative. So many times MCQ question is coming here. Alpha value negative for which material? Only semiconductor, only insulator, or both semiconductor and insulator? Alpha value negative is for both semiconductor and insulator. Yes or no? So this is a question coming. Entrance also they are asking like this. So please you remember alpha value negative for both semiconductor and insulator, but positive for conductor. What do you mean by positive? Meaning the temperature increases na resistance will increase, but negative meaning is what? Temperature increases means resistance decreases. So that is the negative positive meaning. Remember. Okay. So 7 points we completed. Now another 4 points, listen. Effect of temperature on resistivity and resistance, that also will see. And the next examples. Okay. So first complete all of you. So your charge carrier is basically for conductor you take free electrons, and for semiconductor it is electrons and holes. Absence of electron is basically holes. Okay, that one will see while studying semiconductor intrinsic extrinsic basically we are studying now, that time you will understand what is electron hole. Coefficient of resistance. It is coefficient of resistance. Resistance, right? This seventh point. Seventh point, what written it is? Again, I am writing that coefficient of resistance. Coefficient of resistance or symbol give alpha. Symbol give alpha. Temperature coefficient of resistance. Completed all of you? Yes or no? Completed, boys? Very good. Now next point, listen. Eighth point. Shall I go next? Did you complete, ma? Temperature. Seventh point is temperature coefficient of resistance. Alpha. Symbol is alpha. Next, listen. The same way do the columns. Serial number, property, then conductors, semiconductors and insulators. Yes or no? So same way I give here. Same way give. Now 8th point I'll write. Okay, serial number 8 point. What property will discuss? The temperature dependence on resistivity. Temperature dependence on conductivity check. Resistivity, conductivity, anything. First write conductivity. Conductivity. Temperature dependence on conductivity. So this is the property you will check. This is the property. Now for conductors. For conductors what happens? All of you listen. If temperature increases, this implies conductivity decreases. Conductivity sigma symbol. Temperature increases na conductivity decreases. For semiconductors. For semiconductors, remember, if temperature increases, this implies conductivity increases. Okay, that's why alpha value negative. Now insulators. Insulators. For insulators, same thing. If temperature increases, this implies conductivity may increase. May increase. Okay. So this one you remember and write. This one you remember and write. So eighth point about temperature dependence on conductivity. So here what is happening? Temperature increases, conductivity decreases, sigma decreases. Okay, resistivity increases. Here what happens? Sigma increases. Okay, now ninth point, right? Ninth point. Ninth point is temperature dependence on resistance or resistivity. You can tell. Temperature dependence on resistance or resistivity. Same will come here. So you write on resistance. Resistance. Resistance give R. Knowledge. Now remember here, if temperature increases, your resistance increases. Resistance increases. Electrical resistance increases. Electrical resistance increases. If temperature increases, resistance decreases. Okay. Remember here, resistance decreases. And here also same thing. If temperature increases, arrow mark means temperature increases. Okay, in every cases I am taking temperature increase in temperature and checking everything. Temperature increases, same thing happens, resistance decreases. Okay, all of you listen. In shortcut format way I explained you. Arrow mark up means increases. Arrow mark down means decreases. So in that format I gave, but you write in language in exam. You write in language, but I have given in arrow mark format. Okay. So ninth point over. Now last point, listen. Listen, examples. What are the examples here? What are the examples? So examples we'll see. Now for conductors, can you tell what is the conductor example? Copper, aluminum, gold, iron, conductors are metals. Many are there, right? Sodium, platinum, mercury. Yes or no? All metals are basically conductors. Okay. Mercury, platinum, etc. Basically metals. Metals. Next. Semiconductor what? One is silicon, another is germanium. Two things should write. Silicon, germanium, gallium. Okay, silicon, germanium mostly used elemental semiconductor. Some other compound semiconductor also there, but this one you remember. Silicon and germanium. Elemental semiconductors are silicon and germanium. Elemental semiconductors. What are the example of insulator give? Very good. Wood, plastic, mica, diamond, glass. Give example. Wood, plastic, mica, glass. Okay, etc. Yes or no? Diamond is insulator or conductor or semiconductor? Diamond. What about diamond say? Diamond is what? Diamond is insulator. Diamond is an insulator. Carbon is also insulator. Remember, silicon, germaniums are 4 valence electrons are there. They are actually semiconductor, but carbon is insulator because it is very difficult to take electron from the carbon atom. Okay, diamond is insulator. Whoever conducting electricity you put in conductors. That's yes or no? Now all of you listen. All this point you understood. If another point you want to understand here, you can get the point about electron density. Okay, electron density. So let's last point if you want write here. You can write about electron density. Electron density. Per meter cubic, how many electrons you can get in conductors? Now per conductor it is in the order of 10 to the power 29 per meter cubic. So 10 to the power 29 electrons per meter cubic. Here you can get around 10 to the power 16 or 10 to the power 19. 10 to the power 19 for germanium, 10 to the power 19 meter cubic for germanium, and for silicon electron density 10 to the power 16 meter to the power minus 3. Okay. So per meter cubic 10 to the power 29 electrons are present in conductor. Okay. So this idea you keep in mind. Clear all of you? Okay. This is the whole idea about conductor, semiconductor and insulator. Conductor, semiconductor, insulator. All these classifications remember. Okay. And if energy band diagram they are asking, then this third number point you would write as a 2-mark question or 3-mark question with all the pictures. Okay. So everything together I told you. So they asked what is the explain? What is the explain? Classification of conductor, semiconductor, insulator. So all point 1 to 11 point you can remember. Yes or no? This is the first page. The second page. This one, third one. You can remember. Okay. I hope you understood classification. Short mark question, 1 mark, 2 mark questions can happen from this all this data whatever given. Yes or no? So carefully read please. Okay. Thank you. Thank you all of you.